So McMaster Engineering, the message I want to give, has a very collaborative approach to problem solving, both internally with other universities and government labs. We know that no single institution can solve problems. We have to have partnerships which leverage the niches that different universities have, and we've taken leadership in leveraging those partnerships, and also with government labs and with industry. Now, on to today's panel. It's very diverse, representing that theme that I was talking about, and it also represents a variety of industries. So what might you look for today? You should look for opportunities at the interfaces between areas. Areas like manufacturing processes, AI, software, hardware, final products, and their full-scale manufacturing for global markets. So having said that, it's now my pleasure to introduce our panel moderator, Dennis Darby. Dennis is the newly appointed president and CEO of Canadian Manufacturers and Exporters, an organization committed to helping Canadian manufacturing companies advance their competitiveness and drive exports. He was appointed president and CEO of Canadian Manufacturers and Exporters in January 2017 and is charged with leading the continuing transformation of the manufacturing sector in Canada, which continues to represent 1.7 million jobs and more than 11% of Canada's GDP. So working with members, partners, and stakeholders, Dennis is essentially charged with bringing Industry 2030 to life. So he's a visionary thinker, and he thinks of the future. And in that context, develop an achievable set of goals for Canada. Now, Dennis achieved the ICD designation from the Rotman School of Management at the University of Toronto in 2011. He is a registered professional engineer in Ontario, but I want to share his crowning achievement with you. He graduated from McMaster University in 1984 with a degree in chemical engineering and management. And so please join me in welcoming Dennis Darby.
Well, thank you, Dean. That was, yes, exactly as I wrote it. Beautiful. Yeah, and I proudly am a Mac grad, and I'm really happy to be back here today. Let me tell you a little bit about the Canadian Manufacturers and Exporters, if you don't know who they are. It's the oldest trade association in Canada. It was founded in 1871. It's actually the only trade association in Canada that was formed by an act of parliament at the time, the Canadian Manufacturers Association. Today, we represent about 3,000 companies from coast to coast. And about 80% of them are SMEs. And you heard the discussion around how do we help foster innovation, because many of the members of our association are the multinationals, of course, but a large majority are not. And they are looking for ways to improve productivity. We talked about, Dean talked about the fact that about 1.7 million jobs. In today's context, one of the issues we need to think about is about 2/3 of everything we export are manufactured goods. So that means manufacturing still matters, it's still important. And that's why it's important for sessions like today. Because there's a lot of uncertainty in the world. I was at a meeting recently and I said, right now we live in an unknown or maybe an unknowable world of dealing with our U.S. neighbors because we don't know what they want. Or maybe if you know what they want, let me know. But in terms of where they see free trade and where they see changes to the free trade agreement. And why that's so important to the theme today is because we know that it's not going to get easier to compete. It's not going to, the U.S. is not going to say, all right, Canada, you can have whatever you want. No, they're not going to do that. What they're going to do is try to make it tougher to compete. And so that's why we need to foster innovation in our industry in Canada now to be prepared to be competitive here. And we, as you know, we signed a recent, the CETA agreement. So we also have our European partners we have to compete with. And as you heard from the professor earlier today about, Germany, they live and breathe manufacturing. I worked for a number of years there, and I love the fact that manufacturing really mattered. When I came back to Canada, a little bit of the shine had gone off it, but I think our time is now in Canada. So let me also say to you that productivity in Canada, even though I've heard statistics, you would have read one this week, manufacturing output in Canada is at an all-time high in terms of dollar value, in terms of units produced. But what's not, our productivity has not increased for at least the last decade. We've fallen behind, and the reason is companies are not investing in capital and equipment. They're not becoming, and we talk about more innovative, I'm talking about innovations that improve productivity, that improve output, that improve speed to market. And so those are the things that you're going to hear today from some of our panelists who are all experts, much smarter than me when it comes to knowing how and what look for in the future. So I'm going to introduce the speakers. I'm going to introduce the speakers all at once. You can hold your applause. You can, they told me they said they'd be happy to have applause after each of their names, but if you want to wait, we can wait. But I'm going to introduce all four, and then one at a time they're going to come up and make a presentation, and then when we're done that, we'll have a panel discussion, and we hopefully, I've got some really hard questions, and they've begged me not to use them, so hopefully you'll have easier questions from the floor. Okay, so let me introduce the panelists, first of all is Roger Hallett. Is the president and CEO of Festo Canada, headquartered in Mississauga, Ontario. Roger studied electrical engineering at Worcester Technical College in the UK. He's worked in a number of application engineering and product development roles before establishing himself in a sales and business development role. Festo has made significant investments to support automation, so at least wave to the panel, wave to the crowd, that's good. So Roger, welcome. Good morning. Daniel Madrea is the Managing Director of DMG Mori Canada. Mr. Madrea is a professional engineer, has been involved in manufacturing for the past 20 years in various positions in engineering and sales management. He's actively involved in the machine tool industry and serves on the executive board of the Canadian Machine Tool Distributors Association. So, Daniel, welcome. Joris Meine is the Senior Vice President and Country Division Lead for two of Siemens Canada's divisions, Digital Factory and Process Industry and Drives. Mr. Meine is responsible for the overall strategic direction and management of these businesses in Canada, including sales, marketing, service operations within the fields of automation, integrated drive systems, including gear units, motion control, instrumentation, industrial control, and PLM software. So he's a busy guy for sure, so welcome. Rick Hubrick is our Vice President of Digital Transformation Innovation and responsible for the development of digitization and Cisco Canada's Innovations Program. He holds a bachelor's degree in construction management from Tilburg Polytechnic University in the Netherlands, a master's degree in real estate development. I thought that was really cool. Real estate development and project management from Delft University in the Netherlands, and a doctorate from Harvard University with a specialization in real estate technology and investment management. In 2012, Rick was awarded the Queen Elizabeth II Diamond Jubilee Medal for his transformational work in municipal innovation in Canada. Rick will be speaking on disruptive technologies this afternoon at the Cafe X event on the main campus, but we're going to get to hear him first here. So, without further ado, I will ask our first speaker, Roger Hallett, to come up and address. Thank you.
Well, good morning, everybody, and thank you, Dennis, for the introduction. Thank you, Stephen, for the invitation. I'm glad to be back. I think last year we were talking about the concept of 4.0. What I'm going to try to do is talk a little bit more about the practice of it, and specifically what Festo has been doing the last few years. Products and solutions, I'll talk about that. And I'll also just, with a few slides at the beginning, just to show you how we get into the 4.0 world and what it means and what we're thinking about when we do that. So let me first of all say that Festo is a mechatronics company. I think when the name was invented, we realized that this describes us very, very exactly. We are involved in a lot of manufacturing processes and process automation processes. We are typically picking up a part, moving it, manipulating it, drilling it, pressing it, taking part in the whole assembly and testing process. And we're doing that either with pneumatic technology or more recently, more and more electrical and control technology. So this really, we think, is our playing field. So in that 4.0 world, we think we are quite often at the front end with customers who are trying to execute something and find a solution. And as Dennis mentioned, my role here is I'm the head of Festo in Canada, president and CEO. I'll talk a little bit about Festo Canada right at the very end. I'm under orders to be off of here in I think 10 minutes, so I'll try to go as quickly as I can. First of all, just the technology drivers. Professor Zer mentioned much of this when we started. These are the things that we see have happened and are continuing to happen, which make it possible for new kinds of manufacturing processes to be implemented. So Internet of Things, the idea that we can get data from all components within a manufacturing process, the ability to store big data and manipulate it and actually get something sensible out of big data, cloud engineering, mechatronic systems themselves. More and more we are being asked for modular and Lego solutions, solutions which can be easily copied and quickly implemented. So those things are important. And then you'll see here additive manufacturing, augmented reality. I won't talk really very much about that. But these are the technology drivers that are happening, which mean that now we're able to implement things differently when we go about a manufacturing process. But technology on its own really doesn't drive everything. And what we also see is coming from the market, there are clear market changes in market trends and demands. When we're talking to a customer, he is typically trying to deal with one of these topics for the customer that he has. Most of our customers are in the machinery or line building industries. So for example, shipping times. Everybody wants to be able to order their vehicle, configure it personally for them, and get it the following Monday. So there's a lot of pressure to speed up shipping times. And that also comes with the reality that shipping components or products all the way around the world, there's an ecological impact to that. And that's something that people also start to get sensitive to. So definitely the idea is there about smaller batches and producing more local to where markets are. The little cars down in the right-hand side, the idea that, as I just mentioned, everyone wants to configure how they get their product. Right now, if you buy an iPhone, I think you're limited to 3 choices. But in the future, are people going to be happy? People would like to have a green one and a red one and every other configuration. So there's more and more a demand in meeting individuals' requirements and needs when they want something which is more specialized to them. Engineering times, shorter engineering times come with everything. It goes with this picture in the bottom left-hand corner where customers are trying to get their products to market quicker. Once they've had the idea, they want to be in production as quickly as possible. And engineering times is one area where technology is enabling us and other companies to squeeze that time down and help our customers deploy their manufacturing much quicker than they were before. And of course, money is a big factor. So we see the technology being available and the market demands changing, which is really creating this environment where manufacturing is going through a process of renewal. At the center of it, we see the smart factory or the agile factory able to rapidly reconfigure itself or rapidly respond to changing demands, whether it's in quantity, but also in more individual components, highly connected to a demand-driven supply chain, products tailored to a customer, and then the whole thing very much linked into a business system where the business leaders have access to real-time data and can make real decisions. So that's kind of on one slide what it looks like. It sounds very easy. I think what we see from our point of view is very few people are able to say, I have $50 million, I would like to build myself a agile factory. Most of the companies we're working with are trying to respond to these trends by working within the factory that they have, by upgrading, renewing, changing their process, or adding products and adding solutions to respond to those market demands that I mentioned before. So really, we think that's behind what drives everything. When we put it now, start to put it in terms which we can really work with, we see 4 dimensions to that. We see on the left the verticalization of the vertical integration of all of the components in a manufacturing process. Everything can talk to each other. You can interrogate a sensor to get data from the sensor, and then you can bring that data into a meaningful data acquisition and make decisions with it, and ultimately change the way you do things as a result of it. We see the integration of engineering. It's trying to get your product to the market quicker. If you can be designing how you're going to produce the component at the same point that you're designing it, you potentially can cut out a phase. So we talked this morning about the shadow product or the shadow solution, and Siemens has specific technology in this area as well. It's all about trying to shorten that process and get the product out there as quickly as possible into the market, or even change a product that you have out there as quickly as possible. So we see this is a direction. And on the bottom, you'll see, you may not see it if you're sitting at the front, but at the bottom, horizontal integration on the supply chain as well. We have systems now where a customer can go online, pick his component, press a button, and that demand is immediately in our facility. It doesn't go through, no one's retyping orders, no one's doing any of that anymore. And that means that we can also see demand changing very rapidly. So this kind of horizontal integration is another dimension. And the final piece, which I think as Festo as a company is particularly tuned into, is the fact that there is an impact on this on people, and there is a need to train people to work in this environment. And it's not just as simple as sitting down and doing a one-week training program. There's more to do in that area. So when we are looking at what does Industry 4.0 mean for Festo, what are we doing when we design a product or a process, we are really responding to these drivers and these opportunities. So that's where we come from. What I thought I would do is just show you a few products. Just what does that mean then in reality? So I started really at the bottom. This is in the world of pneumatics. So who would have thought that you could innovate pneumatics? Well, we've got two interesting things in the pneumatics world. It's now possible for us to read data out of the air supply. And we can make the air supply intelligent to the point that it knows that the machine is in idle mode, so let me shut down the air. There's still a lot of processes where compressed air is the main force of energy in a process. So with this device, you can shut down the air, but you can read out data of airflow as the machine's operating, which means that you can start to do real predictive maintenance. Why am I using 50% or 10% more air to make that component this week than I did last week? Something has changed within my process. I'm using more energy. Why am I doing it? So this is right really at the bottom end. But I say that, but it's a very, very practical application of something we are doing right now when we're installing this right now into facilities in Canada. We've gone one step further. We are now at the point of actually digitalizing the pneumatic valve terminal itself. So if you're familiar with pneumatics, you'll know the conventional way of doing it is you connect one air supply and you put all your valves on a terminal, and then you have to choose which valve you want for which application. There's multiple configurations. And once you've done that, you've got a valve terminal which very, very nicely will control all of the cylinders and actuators on your machine. What we've done now, and you'll see I've mentioned new at Hanover because we'll officially launch this in a few weeks' time in Hanover, is we made that all digital. So now it's actually three different kinds of valve, and they are configurable about how they will operate. Are they a two-way or are they a three-way? Do they have flow controls? Any of those configurations. So the idea, and that's all then configurable through apps. So we have apps to be able to configure that. So what does it mean? Well, again, it's faster engineering times. You don't have to decide. You don't have to decide on the configuration at the point you order. You can order it and you can configure it later. You can do the design and the software in parallel to the procurement phase, for example. We're responding for standardization and the Lego modularity, so our customers can buy that and use the same module in every part of their machine, and the only thing different is the software in it that's controlling it. And diagnostics comes with that too. Another area where we are very active is in handling, not only pneumatic but electrical. Everyone has the vision of a robot as being that six-axis red, yellow, green robot that's deployed. We find that there's actually just as many, if not more, applications for gantry robots. This is a three-axis device. It fits very nicely within a machine. It's very easy to install. And what our customers have been doing up to this point is having to do all of that configuration themselves. to decide themselves how to get the part from here to there. And what we've done is we've said, you know what, we'll give you a tool to do that online. Go online. All you need to tell us is the envelope you want to work in, the payload you want to move, and the speed that you want to move it with, and the software will then configure it. And again, if you click the button that says, I like what I have, I've downloaded my 3D drawings, you can now click on the button that will order that for you, and that will show up with you probably a couple of weeks later. So again, we're trying to respond to that, the modularity, the idea of standardization. You can use the same approach all through your machine, reducing the engineering time. We specifically talked to a customer yesterday, it's very fresh in my mind, who at the end of the conversation said, you guys have just saved me weeks of engineering. If I had to do that myself, I would have had to put somebody on that for a couple of weeks. And then the integration into the supply chain. So it's seamless. It's not touched by human hands. So these are a couple of examples. I think I've got one or two more. Yeah. This is something we call multi-carrier system. This is a collaboration that Festo does with Siemens. You'll see Siemens units inside here. It's a flexible transport system. So if you want to be able to make different products on the line, so you don't have a line for the white product and another one for the green product, or even a line for this size and a line for that size, with this system you can run everything down the same line. The carriers are individually controllable. They can stop at different workstations. One gets glued, one gets screwed. You can really flexibly configure how you do your production line. And why is that important? Well, all the reasons that I mentioned before, plus standardization. And what we find with this one is small and mid-size companies, it's very tough for them to try to develop this technology when really what they want to do is focus on making cell phones or filling shampoo bottles or something like that, whereas this system is not quite off the shelf, but it's available as a standard solution which enables them to do that and to get into that flexible manufacturing world really with a low impact. Yeah, so I thought I'd mention one application. This is a cool application because this is an automated pharmacy. In the old world, this is one specifically we've done here with a Canadian company. In the old world, that was the pharmacy environment. Things on shelves, where did I put it? Oh, it's time I reordered that. I forgot to reorder the Tylenol or whatever that might be. And then at the bottom, if you can see the picture, this is the new world where there's a robot inside handling the dispensing of drugs. It knows where everything is. If that rack is full, it can put it over there and it knows where it is. So error rate is much reduced, and that data availability is very easily then going into the supply chain so that the people who manage supply chain know that, well, we're getting low of this product. Or over the last few weeks, we've seen a real increase in flu medication, so maybe we should increase our inventories for that. So without going into a lot more details, I just wanted to give you a feeling of the kind of things that we're doing, and these are all real-life Canadian examples. Yeah, finally, people, we have a training organization within our company which specifically has programs designed at helping people work in a smart factory, what skills are necessary, different skills than there were before. We have our own large facilities in Europe where we are already applying this technology, and we've learned with our own people about the training that they need to have. So we deploy that as well. So that's the fourth of the dimensions. And then finally, just to say who we are here, we have a mechatronics center in Mississauga, 24,000 square feet, 24 staff all the time, 16 of them are engineers, where you see a snapshot of it here, where we are working together with customers on helping them to deploy this technology in their machines. We don't make machines. We have a lot of machines come into our facility from customers who then work together with us or work on the machine with us. In Canada overall, we're 150 people. And then for the Festo Canada part, my part, the training business is another 250 people making learning systems. They're out of Quebec City. So that's the other leg of our business. Okay, so that's me done. I hope I could give you a bit of an insight of who Festo is, but more specifically what it means, what all of that big stuff means when somebody comes to buy something and put it into their factory. Thank you very much.
Thank you very much, Roger. Well, now we'll ask Daniel to come up and give us a little bit of an insight into his work. Okay, thank you. I'll get it your way. Okay, very good. Right here.
Thank you, Dennis. First of all, thank you everyone for coming. I hope that we all leave with one great idea from here, and that's going to be well worth it. So I'll try to take it a little bit into real life production application. How do we apply everything that we talk about and get improvements in creating products? So as you see here, there are about 4 steps here in the Industrial Revolution, and apparently we are in the 4th now, where everything is going into the digitization of manufacturing. So the way I look at it and the way I think Industry 4 is, it's the ability to adapt your own path to your destination that you're trying to go in real life. So now the destination can be like a GPS position or a product that you're trying to create. And I think everybody's using Waze, and this is a great example of Industry 4 and the adaptability of a product that helps you so much on the fly to adapt yourself and become efficient. Kind of the same concept is applied in production. So I have an example here for creating a product. It's a factory, and then we have here a production control unit on the right that keeps the link between suppliers, production, manufacturing, and the end user or the manager that can see everything that's happening at all times. This is a shop floor monitor. It's for real. This is we have in our production lines in Germany. All the factories have, and as everything is customized, every single product that is created has one of these production shop floor monitors. I was just thinking about and listening to the presenters prior to me and looking at what's coming, and I just realized that, Stephen picked us very, very, very well. Dr. Z presented the concept of everything included, and then I just realized that, we use all these products from Festo, we use the products from Siemens, we use some from Cisco, and other software, and then we try to put everything together and create this product that will give all our factories the edge to be competitive for the future. And at the end, we all know that technology, I think, is the only drive of the development of society. And, the better we become on this, the more we increase our standard of living. So again, the shop floor monitor just makes the link between, as you can see, logistics, warehouse, production, planning, design department, sourcing, and sales. So that unit knows what's happening with everything that is concerned to that particular working station when a certain product is produced. And being able now to access all that, as you can see in this side, now we are able to adapt on the fly to everything that we need to create. And that goes from the order information, workflow, all the operational acquisition, and eventually at the most important thing as the status information that's right at the bottom. So you know exactly where you are, what's missing, and when is it going to be completed. You know, at the heart of all this, it's our HMI, it's a human interface that it's called Silos, and that sits on top of any control that machine can have. You know, it just happened that at this point in time, this is implemented on only Siemens and I believe Fanuc and Mitsubishi controls. But I think that this was the first step into the machine tool business of the digitization of the machines. So what DMG Mori did by developing this interface is creating like an iPad in the interface where you can create anything you want to be able to access all kind of information and then give also your customers the ability to create their own applications. And you know, as you can see, you know, they are all color-coded depending on if it's about production, utilities, is for the support of the machine, regarding the configuration, or just to monitor the machine status. This is just one example, and the easiest one, this was already available probably at least 5 years ago. This was the Messenger, where you can see in a simple view the status of all your machines in the shop and you know what is wrong with it. But however, this only gives you the status, you only get the information, but you don't have any ability to adapt. Therefore, you know, we had to move this whole technology forward now and develop the process chain. So this process chain now, this starts with preparation, where you create your CAD data, you can create your CAM data, your toolpath, your program, your simulation, and then you can run all this through a virtual machine, which is an exact copy of the machine that you have on the floor, and this is called DMG Mori virtual machine. And I know somebody has asking for if you can make a copy of the machine, and this is what this is, a software copy of the real machine, which copies the exact, you know, servo parameters, acceleration, deceleration, tool change speed, cutting forces, simulation, and everything else like in real life. So when that program goes on the machine, you know exactly what you're going to get. Then we go into the manufacturing, where now we are creating a job manager. We have a performance monitor application and the condition analyzer. So we are moving now a little bit more into having the opportunity to adapt while we manufacture, and this is given by our ability to collect data and work with it. So I'll go a little bit later on into more details into this condition analyzer and how it helps us adapt. You know, as far as machining then, we have created a lot of technology cycles just to make it easier for people to customize their processes and applications by not having to develop everything that they need to do. You know, you just get a screen and then you just have to fill in the blank. It's kind of parametric programming. And then the control will automatically create your safe toolpath. There's an Industry 4 sensor package available now these days on the machine. That's exactly what Roger was talking about. All the sensors now are on the machine, and you can collect the data through them, and then you have to figure out what you're going to do now with the data in order to be able to adapt and be efficient. Then last but not least is the service functions. You know, service agent, the developer applications, you know, these are all just tools that are added at the end in order to be able to reduce the downtime on the machine and giving the customer, the developer, opportunity to create his own custom-made applications. I go into a bit of detail here as far as machining goes. You know, just very simple example, just to save time, for example, tool sorting cycle. So based on the part process, in order to minimize your nut cutting time, you can find out what's the best order of having your tools into a tool magazine. With the measurement cycles, you know, to make sure you ensure your workpiece quality, use a 3D quickset, which is adjusting the centers of rotation for your rotary axis on the fly to ensure the accuracy on your finish pass, for example. Then there's a lot of grinding applications as well that help create grinding cycles on the milling machine. As far as monitoring cycle, just to ensure your process reliability, this MPC, machine protection control, you know, it helps you control and create a very stable manufacturing process. This is what everybody who's into manufacturing wants to have. Now, moving forward, the condition analyzer. As you can see, you know, now we started to put sensors into everything. And, you know, not because we have too much money to spend or we have nothing to do, but you have no choice. But in order to be able to have an idea of where you are at each point in time and to monitor the performance of each component of the machine and to know exactly when you're out of range, we have to have the sensors. And then all this data that is collected by the sensors is stored on that control and eventually can get on the cloud so everybody can see. And then because of this, now you can visually diagnose the problem that you're incurring or take measures to avoid the problems that you don't want to have. Eventually, all this data that is extracted from the machines, including all the status of the machine, it'll be on the cloud, and this can be at the factory level, all the multiple factory levels across the world. For example, you know, there are companies that are doing that already. Like I know Schaeffler, they did something like that very, very successfully. As far as the condition analyzer content, you know, this is just to really recognize all the machine's problems early and avoid them, optimize the usage and maintenance of the machine, and target information for maintenance. Process monitoring. This is very similar to the condition analyzer. Other than that, it creates short-term reactions when recognizing overload. So it has adaptive technology included in it. And then there are a few new concepts like analyzing the process and creating certification for different processes and programs. And these are on concept basis. So as you can see, this is an evolving industry. For, like Dr. Zay said, is not going to stop here. It's a long path, but you do have to start somewhere, and you have to make sure that it's feasible for your application. You know, as far as the condition analyzer, there is a lot of data that you can look at. Now you have to look what is important, and you know, you can collect common machine data like how efficient your machine is, or you know, this is not that important for production, but it's important in the big scheme of things. You can check your coolant water unit. You can check your filters. You can check the tank level. You can check your paper if it's clogged. You know, as far as the cooling aggregate or the cooling unit for your spindle, you can check the temperature, and you can check the the flow of it as well. For the electric cabinet chiller, you can check the filter, the motor protection control, and the temperature. For the hydraulics, pressure, filter, tank level. Then you can check each one of these axes or the main spindle. You can see the speed, position, power, monitoring of the thrust force or the growth of the spindle if there is any. And then pneumatic, of course, that's exactly what Roger was talking about before. So the bottom point is that we need to increase the overall equipment effectiveness. And this we do by recording, analyzing, and then adapting on the fly to the new conditions that are given to you. Of course, this is going to help you improve your machine availability, help you project your maintenance schedule, and eventually even further, create a more guided maintenance that can be done by customers themselves. And I have here some pictures to better understand, on the cooling system, for example, and you can see all the items marked with an asterisk are already produced and can be purchased, and the other ones that are not, they are in process of creation. So you can see the paper band filter position sits properly or not. You can see if the filter is clogged. You can see the coolant level. And if you go further, you can also see the pressure as well. And a lot of companies are already implementing this. As far as the hydraulic unit, temperature level and pressure, it can be checked. And you will know right away if it's in the right range. Same thing with the pneumatic systems. Same with the cooling aggregate. Same thing with the spindle. You can see the bearing temperature, and you can see the growth and the vibration, if any. So that way you can avoid future failures. And same thing goes for the control cabinet, and eventually we're going to implement something on the ball screw drive as well, as far as pre-tension of the ball screw and the temperature of running it. MPC, this is the most common used piece of software that it's created really to avoid and adapt on the fly. And this, I must say that most people buy it these days when they purchase a machine from us. Because this way you can check all the in-process vibration, you can quickly shut down the machine in case of a tentative crash, or you can monitor the torque of your tools, and if you are avoiding or if you are pushing the machine or the spindle too much and destroying it, or you can destroy, or you are destroying your tools. So all this will give you a stable process and increased availability through avoidance of tool breaks, imbalance analysis, and you can create targeted maintenance. Most importantly, avoidance of machine interruption. And these are examples now that in real life, what is happening today. These are things that are offered today so customers can extract all this data through all these sensors and then decide what to do with them. And that's going to be the next level where my colleagues from software will take over and now play with this data. And you can see machine protection, the MPC that I told you about, that's an app on the Silos control. The spindle growth sensor, again, it checks and it tells you the spindle displacement and gives the possibility to adjust on the fly for to improve your accuracy. So it gives you precision and optimize your process, really. And then to have a safe process, of course, especially if you really need coolant and you cannot take a chance for the flow to get reduced, then you have a flow rate control unit as well. Same thing on the turning side. So all these sensors are on the machines and available to extract data and then for the data to get manipulated. So again, at the center of all this is the Silos control and all these new applications that are developed and the possibility for customer to create their own. Ultimately, this is where everybody would like to be. You know, collect all the data from all the machines, all the factories, through all the servers, and have everything on the cloud so people can see and make the decision based on that. That's my presentation. Thank you very much.
Thank you, Daniel, for that insight. Joris, you're up next.
Good morning, everybody. I'm responsible for the industrial business at Siemens that covers the manufacturing industries and the process industries. I was here 2 years ago to talk about the introduction of Industry 4.0. And now I want to spend the next 10 minutes a little bit what it actually means for our customers. So what Industry 4.0 means for our customers is we want to implement a digital enterprise for them. And it means that we digitalize whatever they are doing. Their product they are designing, which is already happening a lot. The equipment that they are using in their processes, and the process itself. So to create a complete digital enterprise. And why is that so important? Because we differentiate, and we see that our customers differentiate themselves through innovation. And it's about innovating fast. And innovation is not happening the first time right. It's happening by people, and people make mistakes. And successful companies, successful innovators are companies that allow their innovators to make mistakes without jeopardizing the company and the future of the company. So we will come to that, how we accomplish that. I was here 2 years ago, so 2 years have passed, and I'm a bit impatient and a bit frustrated, if I may say, about the lack of progress I have seen in Canada with the adoption of the technology. Yes, we have been working with global companies that are based in Canada, but I see that a lot of small to mid-sized companies are still in waiting mode. I was part of a panel on, with Plant Magazine, and they did a survey, and the survey is done in October, November last year. And they asked people in management positions in the manufacturing industry what percentage of their revenue is invested in innovation. Now, you see these percentages, but the most important box is the middle box, that 80% had no clue. That is a concern. Because in other parts of the world, that box is a little bit smaller. We have a lot of companies, I mentioned global players already in Canada that are experimenting and working with this technology, with the implementation of a digital enterprise, but the vast majority is not yet here in Canada. Now, what are the main drivers why companies should do this? The first worry that manufacturers have is, am I designing a product that my customers will like? And when they have that idea, can I do it fast enough so I'm ahead of the competition? And once you figure that out, then it's important that you produce it in such a way that you make money, so that you also keep the costs under control. A given is that the quality is there, and that you don't lose your information so that it is safe. So these are 5 main drivers that push companies to implement a digital enterprise. At Siemens, a digital enterprise, we cover both the manufacturing industries and the process industries. Manufacturing are ahead of that because the flexibility and is there higher. and the pressure there on innovation cycles and in the process industry. So manufacturing here is leading. Siemens is uniquely positioned as a company because we offer value through means of software and services to our customers in their 5 steps of the manufacturing process. So it starts at the product design. We are also a PLM software company. We have software that simulates and designs the production process of the manufacturing. We have software to engineer the production, PLC software, Cinemeric software, like for companies like DMG, for example, or Festo. We have software to monitor and to service the production itself. So in this way, we can offer a software platform which allows us to speed up these 5 steps, logical steps, which allow us also to speed up the innovation cycle. Now, what we do is whatever is happening in these 5 steps, we create a digital twin of that, so that our customers can simulate what they are planning to do eventually on the shop floor. And that simulation allows to test things in a fast way, so you avoid designing everything to find yourself in a position on the shop floor when all the resources are deployed, to find yourself in a position that something is not working. That can take your company out of business. Yeah, we have, you see pressing examples of that in the aerospace industry, for example. Now, an additional layer is that in these 5 processes, once they are running, there is a strong value add to capture data and store that data on a medium. It could be on a local private server, or it could also be on a private cloud. And there is a new element of value add, if you have all that data once there, is to turn that into information that you feed back into your virtual model. So while you are producing, you collect the data, you run apps on that, and you feed back that information in your virtual model to optimize that. So in essence, it allows people, manufacturers, to innovate faster. So I talked about the 3 digital twins. Already since many years, everybody in the manufacturing industry has a design in 3D, but also the machines used in the production, you can have a digital image of that, so you can simulate how your production will run, look at cycle times, optimize position and ergonomics, and you can also simulate your process. So these are the 3 components that are unified and are structured into one data model. Important is, manufacturing is not done just by one company. It's part of an ecosystem, so that the suppliers are also on the same platform and can exchange information through a data backbone in real time with their customers. And in Siemens, we use the data backbone Teamcenter, where we are market leader worldwide. This process can both be implemented with end users or with machine builders. So the same applies from machine concept to machine service. You can apply actually that digital twin model. The software systems that are deployed are totally integrated automation software. That is the software that is running in robots, in numeric machines and machine tools, in PLCs. You have the software that is used to organize your PLM process. And then you have the software, the manufacturing operations management, which is the scheduling, the planning of your processes. So both management information systems and management execution systems. That is actually software to help run your plant. And that is all connected to a cloud-based platform where data is stored that then can later be used to feed back into the actual process. So a call to action for manufacturers, what we are recommending customers to do is first of all a request to question standardization. What are the self-built barriers we impose on ourselves that prevent us from going to Industry 4.0? It's usually standards from the past. I speak with customers and they said, why are you not changing this? Oh, I'm using, for example, Rockwell since 20 years. My electricians, that is what they were taught. I said, when were they taught that? 20 years ago. Okay. That is not what we hear in South Korea. That is not what we hear in China or in Taiwan. This is a limit that we put on ourselves. So we need to question standardization. The second thing is, and that is to identify low-hanging fruit, is we look at the entire existing manufacturing process, and we can help our customers by doing an assessment to see where are potential bottlenecks, where is a lot of time spent or money spent in the entire process. And we map that out, and we look for areas where we can, with low effort, but with high impact, make a change. We also look at the areas where, with high effort and high impact, changes can be made. So that assessment is a good mirror for us and for our customers to see, okay, where do we get started? And then try to start with a pilot. Look for an area, low-hanging fruit, where you say, you know what, with little effort of digitalization, we can make a change. The dynamics that this will generate in the organization are immense because everybody will be watching what is happening, what is coming out of this. And that change then will spread out and create a momentum where other people in the organization will look at things differently. Thank you very much.
Okay, now our last speaker will be Rick. He's going to lead us then into the questions at the very end of it. So Rick, over to you.
Thanks. All right, good morning, afternoon almost. I'm going to, based on everything I heard, maybe change up a little bit the flow of my talk, including trying to make it shorter so we have more time for Q&A, and I know we started late too. So I work for Cisco, and we are a technology company. You heard from the introduction that my background is in construction, so I know nothing about manufacturing, and maybe nothing about IT as well, so we'll see how this goes. But if I think about what I heard this morning, there's a few common themes that kept popping up, and that was we're going to have sensors and machines and things being connected, so connectivity came up. For it, we need networks. We need infrastructure that moves and connects moves the data from those connected things and connect those things. That's what we do. We also talked, and maybe not so much, but I'm sure it's in all of the back of your minds, around securing things. How do we make this super safe and secure in a world where we get hacked, each and every one of us? As they say, there's two kinds of companies, those that have been hacked and those that do not know that they have been hacked. This is the new reality we live in, and when you connect more and more things on your plant floor, you're going to be a target, equally so. So cybersecurity is the next big product family that we're leading with. Thirdly, we heard about collaboration, partnerships. We have to innovate together. This is about collaboration, and that's what we do. Our third large product line. And then last but not least, all this leads to tons and tons of data that is becoming explosive, that needs to be stored, both in the cloud, which really means someone else's hard drive, or at the edge, and that's where the data needs to be processed on your floor. So around data management, data centers is the fourth product line. So although I may know nothing about, frankly, IT or manufacturing, I think the glue that brings all this together, what we spoke about this morning, is networking, is technology. And that kind of makes sense when we look at the evolution of what we heard, first, second, third, and now fourth industrial revolution. And then we throw in terms like digital transformation and innovation and digitalization or digitization, depending on where you are. We do that, I think, to collectively confuse our clients so they all come running at us and say, please help us solve this problem so we can all sell more. But at the core of it, we all share kind of the same challenges. And all this technology and what we kind of talked about is almost irrelevant. And that is, how do we stay relevant and make sure that the next Uber or Airbnb doesn't end up in our industry, the manufacturing industry, and makes us irrelevant? How do we increase productivity and reduce cost and do what we do better and smarter? And how do we create new opportunities? Because we know that the world in front of us is changing faster and faster, and if we don't innovate and try to reinvent ourselves, we're going to be irrelevant at some point in time. And I think, Joris, you showed some of the data. In Canada, IDC did a study amongst business owners and last year, and 97% of Canadian business owners know that digital disruption or digitalization is going to impact and disrupt their business within the next 3 to 4 years. But to Joris's point, the Canadian business owners, only 16%, and we think it's inflated, actually has a plan, knows what to do about it, how we're going to take all these amazing technologies and infrastructures and capabilities that we have today to protect ourselves in an uncertain future that is really earmarked or branded by digital transformation. And I'll flip through some of these and I'll get to really my conclusion quick, because you've heard it all. There's enough table stakes technologies. IoT is one of those terms, but there's nothing new about IoT anymore. It's here, it's done, millions, billions devices are going to be connected. Everything is going to be mobile, including on your factory floors. Everything is going to be manless probably at some point. Will be managed in the cloud, data analytics, and now we get drones and AI and mixed reality. All those new technologies going to add to the complexity or the opportunity that is going to allow or require every company in every industry to reimagine themselves. So I'm not going through some of these examples for the sake of time, but I'm showing those, the first three particularly, because they're the industrial sector that up till recently have said this digital stuff is not really impacting us. We're not a retailer, we're not a software company. And our argument that is wrong, because in any industry, construction, mining, utilities, manufacturing, we're going to see digital technologies already, the convergence of IT and the convergence of systems and automation happen faster and faster and transform the businesses that we run. And so I won't go into this because this would expose my lack of understanding of your industry probably, but you all spoke about we need to lower downtime or reduce downtime and maximize efficiencies and reduce energy and all those topics. And these are the business outcomes that we want to achieve, for which we need to find the right technologies, the right partnerships to deliver value-added and creative solutions that help us stay relevant and drive efficiency. And as I mentioned, the key and common factors are really around the technology piece that's being introduced. From how do we move from siloed networks, your traditional SCADA or your proprietary infrastructure that you may have on the factory floor versus the IT infrastructure that you have in your carpeted space. How do we see that merge? How do we look at expanded security vulnerability? How do we look at the data overload and data management? These are topics and business discussions or digital strategies that we're going to need to resolve if we want to have an agile strategy and be able to change our businesses faster. And for it, we need to start to think about the introduction of IT or digitization in every aspect of our business. Now, we look at this from banking and retail and manufacturing and mining and whatever industry. Every customer that we deal with is going through this journey. And if we try to unpeel that onion and say, what do they all have in common if they want to successfully take advantage of all this? There's like 5 key components, and I'll do this quick. First one, the appreciation that we need to start to connect things that were historically disconnected and we couldn't get to the data or it was proprietary, need to all be connected and be able to communicate with one another. This means we need to connect our people, our processes, data, and things, similar to what we already heard. Then it needs to be digitized. We can connect to something that still is proprietary and it can't do anything with it. So we have to start to automate and digitize our solutions and our technologies. So now we level the playing field and elevate the bar. We call that hyper-connectivity. We put the word hyper in front of it because you've heard so many times the speed of innovation is coming faster. We need to have faster innovation. So we just add hyper just to create another buzzword. Hyperconnectivity. Now I have everything connected and systems digitized. I need to have the ability to visualize and do something with the data. And I think you've seen plenty of very good examples, because only then we can start to create hyper context awareness and hyper decision making, informed decision making that allow us to reimagine and redefine and redesign our processes. Now, this is kind of the technology part, the foundational pieces we're going to need to start this journey successfully. Maybe more importantly is, and then I think in the introduction it was mentioned, is the need for partnerships, and not just amongst ourselves. So how a Cisco and a Rockwell and a Siemens all start to partner, and maybe 10 years ago we wouldn't understand why we would, but today we very clearly understand if we don't work together, we won't collectively innovate faster. But also partnerships with the academic sector, because a lot of the innovation happens right here through applied research that we can tap into that allow us, as well as the small, medium enterprise, to access innovation that otherwise would be unaffordable. And by partnering in an intelligent way, we get to hyper execution, because it's much faster innovation that's happening. And all this is for nothing, everything we just spoke about, without a clear vision. What are we trying to do? Are we just going to create the same widget and the same thing, trying to play the same role in the same supply chain, but just do it now through IT? Or do we collectively need to reimagine what our futures look like and what our purpose is going to be? And that requires a vision. And only when we have that, we can have hyper agility or hyper agile business strategy that allows us to continuously be prepared for a rapidly changing future. So in closing, we'd say you start to have to be able to dream it, and that is very difficult. It seems easy, but that's hard, and frankly, that's why events like this and relationships with the academic sector are so important. And if we dream it, we believe it, and then we achieve it if we work better together. So thank you very much.
Thank you, Rick. I'd ask the other panelists to come up on the stage here, and we'll begin our Q&A. This is a double-edged sword. I've been told by Stephen that if you don't ask questions, that he's not going to give you lunch. So on the same token, the longer you ask questions, the longer you wait for lunch. So you have to balance the two. Anyway, I'm sure I know there are a lot of questions last year from the floor I heard. So I'm sure there's some. Anyone want to start us off? There are folks that'll have. Oh, there's one right at the front. I think we have some microphones somewhere so everyone can hear. If you don't mind using that, that would be great. And let us know who you're directing it to, or let us know who you're directing it to, or to any one of the panelists. Just let.
Good morning. Thank you for the presentations this morning. My name is Florent. I've spent the last 10 years in R&D in industry and operations management. And there is two questions that I would like your opinions on. The first one is my biggest asset, my biggest pride, and my biggest frustration has always been people. So, and I'm talking shop floor employees who do what they are supposed to do, but also support functions, sales, supply chain, etc., and management. You tackled a little bit the approach that you have for training people and going through this transformation. Could you please elaborate on that? And my second question that we are shut up after is there was very little to no mention during the presentations about the end product and quality control. Could you please comment on that as well? Thank you.
Yeah, so thank you for the question. Maybe I'll take the first part of the question specifically about people. We have implemented, or we are implementing this kind of technology at some of our plants in Germany. And I think some of the things we found in doing that, and it's also common sense if you look a little bit back in the history as well, is by involving the people in in the process of the change process and also designing the training that they need. What we've done in one of our facilities is we put training in the center of the facility. It's no longer a room that you go off site to, it's actually in the middle, and it's got glass windows all the way around. So people are encouraged to go in there and update their skills and feel that it's also the part of their responsibility. So it's kind of getting ownership, and it's involving them in the process so that they don't feel alienated by the whole idea that things are changing. And it's a long time in history now, but when they first started to put weaving machines into factories, people were on the street rioting because they felt that was the end for them and that they would never ever work again. So I think it's a lot to do with managing, in quite a emotional sense, managing their expectations and including them in the process. At the end of the day, I think somebody mentioned it's not a job killer. I think Professor Zare mentioned that. So, but there obviously is a risk. That's what people are going to see, and robots are going to put me out of work. So, it's a tough subject, but I think involving the people in the process is really, the starting point for that.
Thank you. Anyone else want
Yeah,
to weigh
I'd
in?
like to
Please?
add a point to that. Especially the people and the training aspect for small to mid-sized companies can be a challenge. I see an opportunity in what Dr. Zay mentioned, the cooperation in the triangle, education, government and industry, working together to de-risk that transformation and to help manufacturers to get over that hump. Then from the dynamic that creates, things will start rolling. I see that as an opportunity.
There was the second part of the question is with respect to quality control. Does somebody want to take that one on and comment on that? Sure, go ahead.
I can talk a little bit on that. So first of all, regarding the people, I'll just touch very quickly. We had kind of same issue, and in the last 2 years we started, for example, sending all our service technicians to Germany for training. And 2 weeks every year, everybody goes to Germany for training. And it's amazing how some of these people changed. They already felt appreciated, they were more knowledgeable, customers more happy. So, the whole dynamic changed. Before it was so expensive, and everybody's thinking, why should I do that? Is it worth? The guy's gonna leave. But it's not like you have a choice. On the quality side of it, I think there are two things that I see. First of all, because we are in production, we build machines, and the scrap rate, by having all the sensors, for example, to check your coolant pressure alone, or to check your vibration, all this, this, first of all, is going to reduce your scrap rate. And then being able to adjust your machine accuracy on the fly, then you really get better parts at the end with better quality. Then you de-risk your whole process and create a more stable one. That's.
If I may add to
Go
that,
ahead, please.
and maybe in both of these, maybe to take a bigger thought here. I think quality control is to what is it, the widget that comes out of the machine. I think that's what we're talking about. But we may have to rethink completely how we think about quality. And if we think about an Uber, where we look at two-way quality control, does it sound odd or is it just me?
Really
Yeah.
good.
Two-way quality control. Is it closer or further? So maybe we need to have a different feedback loop with the people that actually use the products that come out of it. On talent, I think the problem is much bigger than we give it time for here. I think we have a huge talent gap. 6 out of 10 jobs today did not exist 10 years ago. We know we're going to have the problem compounded in the next 10 years, but still, and obviously it's not McMaster, but everybody else, we're still delivering skills and talent that is based on, frankly, older thinking and old technology. So maybe we are not looking necessarily for people with a certain skill set, a technical skill set, but more like how can they be more productive participants in this agile world where we need change. And I think certainly our investment that I know Siemens does and you guys do probably too, is heavily invested with the academic sector on how we can rethink the whole education from K to 12, higher education, and then continuous learning, because that doesn't go away either. And I think that's a huge task for us in this new world.
Thank you. There should be another question over here.
My question kind of goes to everybody. So there's this new generation that thinks that, yeah, destructive technologies are good for the industry. I have a platform that is trying to connect toolmakers and manufacturers. Now, Joris, you said something about this because we find that it's very hard for these small and medium-sized companies who are the most vulnerable to really adopt this technology. What is the industry doing to kind of help these new technologies be more adopted by these people who need it more?
We are preparing partnerships in the different provinces between government, education, and industry partners, companies like Festo and DNG, to come to a hub which is an extension of an education center where students are exposed, or people of small to mid-sized companies have exposure to the technology without having to go through the capital investment of buying the latest DNG machine, for example. That machine will be there available, having the latest access to the latest software, and having also access to very bright minds that have that can share their knowledge with people from small to mid-sized companies.
Somebody else want to address it? And then
Can I maybe speak to that as well? I mentioned that we operate a mechatronics center. I think a lot of our experience is small to mid-sized companies coming in off the street with a great idea and maybe the first or maybe the second idea about how to manufacture it. But it's very difficult for them to have the time, and it's normally time, it's not so much money, it's the time to take a new look at everything and really try to start again. So I support what Joris says with, there are the hubs and ideas about how to bring academia together with industry. We do it a little bit on our own because we saw a gap and we saw people asking us for it. But I think it's really important. The bigger companies, they sometimes have the same problem. They don't have the time. They're so busy doing what they're doing, and when they're not busy, they probably don't have the money to spend. So we need to do something to help people get started with it. And I think Canada especially, there's other countries in the world, we talked about Germany, where this is a lot easier. It's not so easy here. We've got some fantastic ideas coming out of colleges, but getting it into the market is really one of the biggest challenges here, I think.
Okay. Another question. There's one right near the back there. We can.
Right
there.
This addresses some of the information from the last two speakers. I'm with Javelin Technologies, and we sell and support 3D technologies, including additive manufacturing, which was mentioned in the first two presentations. We constantly, and I deal with both the commercial and the academic market, we constantly hear from our US counterparts that we're 2 or 3 years behind in adapting these technologies. And I think this room probably represents part of that 16% that was mentioned in those surveys. So if maybe the panel could comment on how do we change the mindset of that other 84%? Because it's all great information that we have here, but how do we get that other 84% of the Canadian market and the manufacturers getting on board with everything that's been presented here and that's in Industry 4.0?
All right, it's a tough question. Get the late adopters and the laggards. What are we going to do?
I have a thought on this. Your point is well taken, and it's mind-boggling to me because we don't really have a Canadian-only, whatever that means, culture. We're the most diverse country in the world. You would think there's all these ideas coming together that we can speed things up. Doesn't seem to be the case. We're probably one of the most conservative, risk-averse countries and nations that I think we've seen in the world that has served us well. Look at 2008, I think the top 5 banks in the world were all Canadian. Now those 5 banks are not in the top 20 anymore. We then enjoy these moments, but don't take advantage of it and innovate and accelerate because of the opportunities in front of us. So this is, I think, a culture change. I know our conversations with the federal government, who's looking at how do we stimulate innovation and where do we drop all this money that we have. It's not so much about creating another center for AI or blockchain or something, but how do we start to break down barriers for people to be able to take more risk and actually have a more entrepreneurial, I'm not saying we don't have entrepreneurial spirit here, but frankly, the biggest entrepreneurs we have here After we start the company, we move to the US because there's capital and there's market and there's appetite. And we have that missing, and I think that is not necessarily a culture thing, but it's an environment that we need to nurture, that the government necessarily hasn't completely done, and where the private sector has a role to play to facilitate those conversations.
Thank you. Someone else want to comment on that before we move on, or we'll? That's a great answer. We'll questions. I don't know, moderators. Somebody have one picked? Is there one there? Oh, you one at the back, and then we'll do one more at the front here. Somebody want to? Go ahead. Go ahead, yours.
Technology is very heavily used. We use it now already to program drives wirelessly. Safety relevant signals, e-stops. The signal is sent wirelessly to the PLC, so that is also possible. Wireless connectivity is an absolute must the minute you start to capture data from the machines that are running to the cloud. So wireless technology is really a game changer there, yeah. So, and it is used already actively, yeah.
Another comment, or before we?
Is it, how close do I have to go, Steve?
You're doing well.
Okay.
You're doing well. You're doing well.
Saying get closer.
Yeah. I think you're on radio. You're on radio.
I think wireless is the way forward. We see this in the enterprise sector, and particularly in the industrial sector that hasn't historically really done or looked at wireless. Building a wireless network is as critical as building a wired network or a foundation to a home. And where we see our customers fall short is that we kind of not really specify and design the wireless network for the capacity that you're going to need to require. So we actually see when we build factory networks and factory wireless networks, it usually fall on the wireless side because of not proper design, because the dependency of it is rather huge. We typically think, oh, it's only a bit and a byte, so it's not a lot of traffic. Like I'm not downloading movies when I'm on the factory floor, but at the same time, there's huge dependency, and it does require a different architecture in order to make this really successful. So I'd say call your Cisco partner.
Okay, that was the paid part of this morning.
Unless you did, and that's why you made the comment.
He's complaining. Now he's complaining. Well, we had one last question in the open session right here at the front.
Quick question about standardization. So I think I see in one of your presentation you talk about standardization. So my question is, to the panel, like, what do you mean by standardization in the global environment for the multinational company? And what's your take on how standardization can integrate with the Internet of Things or connected enterprise to benefit the manufacturing sector?
What I mean with standardization is there are definitely advantages to, once you do something right, to create a global standard. But if you notice that the standard starts to age, rest assured somebody else already has a better way of doing things, and then the standard becomes actually a roadblock. And what a good way to question standardization is the education, because then people will start questioning and not only criticizing the current standard, but come up with better ideas. And education is absolutely a must, because I hear sometimes, oh, we are standardized on this or that, only our people know this. Well, that is where the problem is. Your people only know this. Your competition might know a little bit more. So it's education.
I mentioned also standardization a couple of times, and what I was meaning is customers are asking us to help them to design modules, an assembly module or some functional module that then they can deploy all the way around the world and not re-engineer it every time. So whatever's in there is then by default the standard. But that's when I was talking about the demand to have this Lego approach of standard modules that can go anywhere in the world, be quickly deployed, their performance is known, their quality is known, etc. So.
Thank you, panelists, and they'll be around for questions between now and lunch. I know that Stephen wants to give us instructions, but
we'll just have some words from John Jackson.
perfect. All right, so but they've all said they'd hang around and answer your questions. So
now I'm going to attempt something that's, I believe, unprecedented, and that's a 1-minute presentation on government programs. No slides, no PowerPoints. As you probably know, there's a significant investment on the part of both the federal government and the provincial government here in Ontario to support innovation and for, training for folks who are participating in the academic and industrial sectors for science and engineering. Our agency, NSERC, have a very broad suite of programs. I'll be here and available to talk to you about those over the course of the afternoon. I also want to point out a couple of other people who are here today who can talk to you about their programs, beginning first with Gillian Sheldon from the Ontario Centres of Excellence. Gillian, do you want to stand? Perfect timing. Okay, also Anne-Marie Hart, who represents the National Research Council's IRAP program. Anne-Marie, stand up again so everybody can see who you are. NRC and IRAP, of course, have been around for many years and have some very significant potential supports for Canadian industry. So please take advantage of Anne-Marie's presence here to chat with her. Also, I noticed that Rebecca from MyTax is here. Rebecca, do you want to stand up? MyTax are a government-related but independent funding organization, again, with a suite of potential funding activities that you should be aware of and take advantage of. So Rebecca will be pleased to talk to you about those as well. Dr. Vildis asked me to point out that the presentations from this morning are going to be posted. And let me think, what else did he ask me to do? I can't remember, but I can tell you that lunch is ready in the main foyer of the building, and this has been a very interesting session this morning, and I will step out of the way and let you get on with what you want to do.